In this 110, we're going to use GDB. So we've got hello in assembly. This just prints out the message hello world, nothing else, about the simplest program. And so when you run it, let me get this here. Okay. And I don't think I need it so wide anymore. All right. Let's do clear and /hello. All right. It just says hello world, and that's it. Doesn't even print the carriage return line feed in this one. Now I can use the debugger to debug it. And then I can disassemble from _start. All right, so here's the assembly code for it. Now, again, I find the colors hard to see. I'm going to set style enabled off and do that again. All right, so this is the third command. The command we entered in the source code was move EBX1. All right, and so here it is moving 1 into EBX. All right, so notice you can see it's moving source to destination. So this is Intel format, or this is AT&T format. It's the one that's backwards. Notice that the command we put in here was move 1 into EBX. But the command you see here is move 1 into EBX. The 1 and the EBX are backwards. That's because there are two flavors of Intel of assembly code, and the one we want is typically Intel. AT&T is the default for Windows assembly, but for Linux assembly like we're doing here, it's normally better to use Intel. It's more familiar. So if I set this to Intel, and now disassemble start, now I will get the same code I put in my assembly code here. Move EBX1, move AX4, and so on. So this will be less confusing. All right, to use Intel format. All right. And so another thing, notice that the constant length in my original assembly code, I put in len, and len was calculated down here. Now this is something the assembler does. It's not in the raw assembly code. It evaluates this, counts the number of characters here, puts it in this variable, and then feeds it in here automatically. So what you actually get is move 0xc. It calculated as 12 and wrote it here. This is important for all compiled languages. You understand what the compiler does. In the preprocessor, it found that number and filled it in. So that's one thing to notice. And the address of the string appears here in this hex format. Again, it doesn't use the symbol. The symbol that we wrote here was just in the assembly code. The symbol MSG refers to this location. And when the code is compiled and linked, it will determine where the data section is and what this actual address is and just fill it in there. So you won't see that variable. All right. You'll see the actual value that it pointed to. And all right, the rest is the same. So now we can put in some breakpoints. I can break at start plus 10, and that will break at this line. And I can break at start plus 15 to break at that line. Now, so when I run, this will have loaded EDX and ECX, but not EBX or EAX yet. So if I run, and then info registers, it should have filled in these values for EDX and ECX, and there they are. But the other values that I'm about to set up EBX1, and that has not happened yet. EBX is currently 0. So, all right. So if I continue to the next breakpoint, which is just going to be the next instruction, now EDX, I should have filled in this one, EBX. EBX should no longer be 0, but 1, I think. And so it is. So you can go step by step and you can see what these instructions do. All right. All right, now EBX contains 1, and as I mentioned before, you can see the memory locations with info proc mappings. All right, and this will show you the memory segments that are reserved for this program to use. These are used by the operating system as a whole. These are the ones reserved for this program, and you can see this one is the executable one. So this is where the instructions are stored. this must be the stack, and it is read, write, execute, which is unusual, actually, that has those permissions. Anyway, all right. Normally, you wouldn't allow it to have write and execute at the same time. I'm not sure why it was allowed here. All right. Anyway, and then there are some flags defined. These mostly involve having executable assembly code that will crash, and you have to use the debugger to examine it and figure out which command caused the crash. All right. So that's what I wanted to show you about that one. I see no questions in the Twitch.